All right, here are quiz 7 solutions for Math 111. Given a polynomial, asked what are all the possible rational roots of it. Possible rational roots are factors of the constant term divided by factors of the leading coefficient. So plus or minus 1, plus or minus 3, plus or minus 1/2, plus or minus 3/2. And it wants us to test those roots. Usually a good place to start is with 1. F of 1 is 2 times 1 cubed minus 1 squared minus 4 times 1 plus 3, which is 2 minus 1 minus 4 plus 3. It'd be really nice if that was equal to 0. 5 minus 5 is 0. Awesome. What we have is that 1 is a root. Alright, use polynomial long division. If 1 is a root, x minus 1 is a factor. So x minus 1 must divide into 2x cubed minus x squared minus 4x plus 3. To get rid of the 2x cubed, we have to multiply by a 2x squared. 2x squared times x is 2x cubed. 2x squared times negative 1 is negative 2x squared. We subtract negative x squared minus negative 2x squared. It's the same as negative x squared plus 2x squared, which is 1x squared. To get rid of the 1x squared, we need an x here. And if you multiply that x times the x minus 1, you get x squared minus x. Subtract here, you get 0. Negative 4x minus negative x is the same as negative 4x plus x, which is negative 3x. And to get rid of the negative 3x, we just need to put a negative 3 here. Distribute through, and sure enough, we get 0 remainder, which gives us some confidence that we did it right. So what we figured out, well, I guess we don't do that until down here. Whatever. F of x is really can be written as x minus 1 times 2x squared plus x minus 3. All right, finish factoring f. Okay. Well, the good news is that we don't have to use polynomial long division again, because we can factor 2x squared plus x minus 3. We need, maybe I do this in a different color. Oops. We need two numbers that multiply to whatever 2 times negative 3 is, negative 6, and add to whatever our coefficient on b is, just 1 in this case. Two numbers that will do that would be, let's see, 3 and negative 2. Yeah. Sure, 3 and negative 2. So what we can do is replace positive x with positive 3x minus 2x. In other words, we can write this thing as x minus 1 times 2x squared plus 3 minus 2x minus 3. That's 3x here. And then we can factor by grouping. These first two terms have an x in common. So you pull out that x and you're left with 2x plus 3. And then we want to be left with 2x plus 3 here, so we have to factor out a negative 1. And what that gives us is a 2x plus 3 in both of these terms. So we can pull that out, and we're left with just x minus 1. Maybe a better way to write that would be we got x minus 1 squared, and we got 2x plus 3. So finish factoring f, and then list all the roots and their multiplicities. Maybe I can jump up over here. So roots are at x equals positive 1. And if this equals 0, subtract 3, divide by 2. X equals negative 3/2. And then the multiplicity of 1 is 2. And the multiplicity of negative 3/2 is 1. Sketch an approximate graph of f. I can do that. Make sure to label the x and y intercepts and show the end behavior. Alright, the end behavior, let's go back to our original polynomial. Degree is odd, so it goes in different directions. Leading coefficient is positive, so it goes up this way and down this way. Y-intercept, again, let's go back to our original function. If you figure out what the height would be when x equals 0, 0 minus 0 minus 0 plus 3, get a y-intercept of 3 up here. And then our roots happen at negative 3/2. Sure, that looks like about negative 3/2 and positive 1. But what's important to note is that the multiplicity at 1 is even. So even though we go through that root, we kind of bounce off this root and end up with a graph that looks something like this. Make that a little bit bigger so it looks like it goes through 1. And we'll call it a day. Maybe I made it worse, but whatever. So there's an approximate graph. That's the end of this quiz.